Hi everyone, in this video, I'm gonna walk through my final project for the course, Machine Learning Laboratory at the University of San Francisco. Using the machine learning library scikit-learn and supervised learning, I'll predict a user's rating on a new anime based on the previous rating and the features of the anime, such as genre, numbers of episodes, and how popular or well-known this anime is. One promising business application of this model is to make it part of the recommendation system. By recommending more anime that the user is truly interested in, we're able to increase the engagement and loyalty of the anime streaming website. The dataset is acquired from the user activity from a user of the website My Anime List. It has 467 rows and 47 columns. So apparently this user is really passionate about anime given the big amount of anime she or he has watched. And among the 47 columns, 39 of them describe the genre of the anime, such as comedy, action, or adventure. And other columns are anime ID, name, type, episode, average rating, and the number of members of this anime. The more well-known this anime is, the more member it's going to have. So as you can see on the slides, the features we're going to use is color in green, and the target variable is highlighted in orange, which is the personal rating this user gave to the anime. Our assumption here is that at least one of the features we mentioned here will be correlated to the user rating. In order to have a basic understanding of the validity of this assumption, the first plot shows that among all of the genre, some of them seem to have a higher rating, such as Josei, mecha, and cars. So probably it's a female user who is interested in mechanical and scientific topics. The scatter plot between the personal rating and the existing rating suggests that this user's rating is not biased to the reputation, so the existing rating doesn't seem to correlate. And this user seems to have a preference for a specific anime type, which is ONA. And finally, again, the scatter plot between rating and members doesn't suggest a strong correlation. Whether it's a well-known or less known anime, it wouldn't have a huge impact on the rating. So given how uncorrelated rating and members are, I just dropped these two columns before the model fitting. And we need to do the pre-processing for categorical variable like type, fit it into the one-hot encoder so it will be spread out for every category. And for numeric columns like genre and episode, standard scalar, so the number will be normalized. And finally, put this two transformer into a column into a column transformer object. One of the major challenges of this model is that user rating is ordinal, so it can be modeled using methods like linear regression, like the continuous numeric data like we have frequently seen. So one of my approaches is to reduce the target variable from ordinal to nominal. Each number is an independent class, as you can see on the slide. From class -1 to class 10, we're able to treat it as a multi-class classification problem. I did a grid search with 3 algorithms and different hyperparameters for each one: logistic regression, random forest, and extra tree classifier. And it turns out that one that performs the best is the random forest classifier. Another approach that I took is ordinal regression. Since scikit-learn doesn't come with this functionality, I used another library, which is MORT. And I did a random search for a bunch of hyperparameters compared to multi-class classification that we just did. Although ordinal regression is more intuitive, the performance of ordinal regression is generally worse. Actually, the accuracy scores for these two models, random forest classification and ordinal regression, are very low, as the visualization at the beginning suggests. The features in the target is likely not to strongly correlate with each other, given the randomness and the nuance of the user behavior. So I think in order to build a recommendation system that really capture the user behavior and user preference, more data should be collected and a more granular and textual analysis should be done. And in addition, other kinds of machine learning algorithms, such as unsupervised learning, KNN, clustering, can be considered. And so we can assign the users to a specific segment where they share similar pattern and preferences. So that's all for my project. Thanks for listening.